Hi, everyone. Here is our first lesson together. We're going to be starting a new topic starting this week, and we are starting system of equations. There's 3 different methods to systems in order to solve for the problem. We have the graphing method, the substitution method, and the elimination method. This week, we're going to focus on the graphing method. Our objective today is that we are going to be determining the solution to 2 equations by graphing. Okay, so how do we determine the solution? First, you want to make sure that both equations are in y equals mx plus b format. Now, I know I haven't been around, but I know and I hope that this should ring a bell. Y equals mx plus b is slope-intercept form. Once the equations are in slope-intercept form, you're going to graph the first equation. Then you're going to graph the second equation. And in order to determine the solution, you want to see where the 2 lines intersect. Okay, wherever they intersect, that is your solution. And you're always going to write your answer as an ordered pair. Okay. Now, with systems, there's 3 types of solutions that we are going to come into contact with. When the 2 lines intersect, that always means that there's just one solution. It means there's only one point that those 2 lines intersect. That's the only time they will ever meet. When you have one solution, you're going to use an ordered pair to represent the solution. So, for example, on here, okay, for this one that I'm looking at right now, if they met at 3, 2, that would be your solution. So you would write 3, 2. Okay, and that's just an example. I'm not sure if it definitely meets there, but that is how you would represent your solution. Our next type of solution, okay, which I'm looking at right here, these 2 lines are parallel. When they are parallel, there is no solution. Why is there no solution? Because these 2 lines will never, ever intersect. So there's no solution. That means there's never an ordered pair that will make those 2 lines cross. They will never intersect. Okay? And just a heads up, if the lines are parallel, okay, you're going to find that these lines will have the same slope, okay, but different intercepts. Actually, I should really say different y-intercepts. Okay, so always remember, if the 2 lines are parallel, your equations are going to look in this pattern. They're going to have the same slope, but they're going to have different y-intercepts. And finally, our third type of solution is infinitely many solutions. What that's going to mean is that these 2 lines are going to be exactly the same line. Okay, so exactly the same line. Okay, and you know what you're going to notice about your equations there? In this situation, you're going to have same slope, same y-intercept. Okay, so there's just a couple little tips for you on identifying the 3 types of solutions. So if they intersect, there's one solution. There's one point that they will meet at. If the lines are parallel, no solution. They are never, ever going to cross. And then finally, we have infinitely many solutions, which is actually going to end up being the same exact equation. Okay? So let's get this show on the road and start off with our first example. Okay, example number 1. First thing you always want to think to yourself is, are these in slope-intercept form? Y equals mx plus b. And we are in luck because they both are. Okay, so I haven't been around to graph with you guys, but a couple little things that I want you to always keep in mind. The first thing you always want to focus on is your y-intercept. Okay. Also, I always say whatever sign's in front of the number stays with that number. So this is technically a -4. Okay. So that's telling me that my y-intercept, okay, is going to be 0, -4. Okay. And then my slope is 2. Okay. Your y-intercept is always your starting point. So what I'm going to do is I'm going to go on the y-axis and I'm going to go down to -4 and I'm going to plot my first point. Now my slope is 2, which I know I always need to represent it using a fraction as far as graphing. And I know that it's 2/1. So what I'm going to do is I'm going to go up 2, right 1, 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 up 2, right 1. Now, I always personally like to reverse, and fill out the other side of the graph too. So if I reverse, I was always going up 2, right 1. Now I'm going to do down 2, left 1, down 2, left 1. Down 2, left 1. Okay, all I did is I just wanted to fill out the entire graph. Okay, so now I'm going to try to draw my line. Hopefully using my stylus pen on my touch screen, this works out nicely. This is my first time using my touch screen. Okay. Totally not perfectly straight, but we'll take it. Okay, so that is my first equation. I'm just going to switch to another color. Go purple. Hopefully that works. Also keep in mind what your line should look like. Y equals 2x minus 4 is a positive slope line, so your line should be a positive line, which I do notice that, so I'm looking good. All right, now my second equation, y equals 1/4 x plus 3. So my starting point always is my y-intercept. Okay, so for anyone who struggles with knowing what to do first, what I think is a good tip is to honestly circle your y-intercept, and that can really help you, understand where your starting point is. So I'm going to start up at 3. Okay, my slope is 1/4. Again, another positive slope. So positive slope, I'm going to go up 1, right 4. Ooh, ding, 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 ding. I just intersected the other line, but I'm still going to continue just to get my line going. 1, 2, 3, 4. Okay, I can't go any more there. Let me reverse it. Reverse. Down 1, left 4. Down 1, left 4. Okay, here we go. I'm going to now draw my line. Definitely got to work on my line drawing. Now, what you're going to see is at that point of intersection, that is going to be your solution. So here we go. This is my solution. Now, you could write one solution, but you really don't need to. The main way to identify your solution is that if there is one solution, you would have to write the ordered pair. So if you notice, they intersect at 4, 4. So my solution here would be 4, 4. Okay? Now let's look at the next example. Okay, we have y equals 4x plus 1 and y equals x minus 2. Okay, so what I'm going to do, my first equation, I'm going to start with 1. When I'm at 1, now I'm going to go up 4. Okay, remember your slope is 4 over 1. So 1, 2, 3, 4, right 1, up 4, right 1, up 4, right 1. If I'm going to reverse, I'm going to go down 4, left 1, down 4, left 1. Here is my first equation. Okay. Now, let me go back. We'll do purple. Okay. Now my second equation, y equals x minus 2. Again, I'm going to circle my y-intercept just so I know where to start. Again, whatever sign's in front of that number for your y-intercept tells you whether it's a positive or a negative y-intercept. So negative 2, I'm going to start on my y-axis at negative 2. Now, when you do not see a number in front of your x, we can always understand that there's a 1 standing there. So my slope here is 1 over 1. It's positive, so I'm going to go up 1, right 1, 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 up 1, right 1. All right, reverse, reverse. Let's fill up the bottom left of the graph. Down 1, left 1, 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 down 1, left 1. All right. So let me make my line. Okay. And your goal right now, once you draw your 2 lines, is to observe where they intersect. Okay. Now, obviously, my lines are not the perfect ones that I'd love to draw. But if you notice, right here is where they intersect. Okay, so my solution would be negative 1, negative 3. Okay, cool. Example 3. I'm going to, again, start with my y-intercept for the first equation, which is 5. My slope is 3 over 1. So I'm going to go up 3, right 1. Okay, I can't go any further, so I'm going to reverse, reverse. And I'm going to go down 3, left 1, down 3, left 1, down 3, left 1, down 3, left 1, down 3, left 1. Ooh. I swear it's my stylus that's making these lines go a little wiggly. Okay. So now let's start with our next one. Y equals 3x minus 4. What I'm going to do, again, I'm going to circle my y-intercept. That's always my starting point. Since it's a negative 4 on that y-axis, I'm going to start down at negative 4. Okay. My slope is 3 over 1. It's the same slope as the first equation. So think back on the 3 types of solutions and what I said. And let's see if we can come up with what the solution is. So I'm going to now go up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. Reverse, reverse, down 3, left 1, down 3, left 1. Okay, I'm going to these lines are so funny looking. Okay. What can you observe about these 2 lines? Well, hopefully you're sitting at home and screaming out, they're parallel, because that's what they are. They are parallel lines. And if anyone can recall from the 3 types of solutions, we talked about if they are parallel lines, they will never, ever, ever, ever intersect. Never, ever, ever. Therefore, my solution for this is no solution. Okay. There will never in a million years be an ordered pair at which these two lines cross. Okay. And if you also recall at the beginning of 3 types of solutions that I talked to you about, I told you that if they had the same slope, okay, the same slope, but different y-intercepts, then it's no solution. Okay. Good. Example 4. Okay. Now, we're going to start with the first one. Our y-intercept is 7. So I'm going to start plotting up at 7. My slope is 5 over 1. So I'm going to go up 5. Oh man, I can't go. Okay, that's okay because I always know how to reverse. So instead of going up 5, right 1, now I'm going to go down 5, left 1. Down 5, left 1. Down 5, left 1. Okay. Okay. Now I'm going to do my second equation, which is at 7. Ooh, that should alert you right away. I'm starting at the same exact point. Now my slope here is negative 3 over 1. So instead of going up and to the right, now I'm going to go down and to the right. Okay, so I always like to start off with always going to the right, but the positive or negative will determine whether I go up or down. So negative 3, I'm going to go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. So my reversing here would be to go up 3, left 1. Okay. Remember, if you have a negative slope, then your line should start up high and go down low. Okay. Now, if you notice with these two lines, this is where they intersected. And don't forget that point, it's on the y-axis, it's 0, 7. So there's one solution. That's the only time these two lines will ever cross. Okay. So those are our 4 examples as far as graphing goes. Now I just have one different scenario to discuss with you, which I have 2 examples set up. And then you'll continue on with your adventure of the day with some practice problems on your own. Sometimes we're given an ordered pair and we're actually asked, is this the solution to the following system of equations? And what that means is this where these 2 lines would intersect? Now, in order to do this, what you're going to do is you're literally just going to substitute in to your x and your y. Okay. So in this situation, I'm working with 2, 1, and I'm going to plug them into the 2 different equations. Okay. So first, let's start with y equals negative 3x plus 2. I'm going to, don't forget, this is, the 2 is your x, the 1 is your y. So I'm going to do 1 equals negative 3, plug in 2 for my x, plus 2. Okay, clean everything up. I know negative 3 times 2 is negative 6 plus 2. I'm going to bring down my 1. Now I'm going to do negative 6 plus 2. Negative 6 plus 2. Hopefully we are super dynamite on our integer skills. Okay, so same signs add and keep, different signs subtract. Keep the sign the higher number, then you'll be exact. So negative 6 plus 2, different signs subtract. 6 minus 2 is 4. Keep the sign the higher number, which is the negative 6. So that means my answer is going to be negative 4. Does 1 equal negative 4? Nope. Therefore, this will not be a solution, but you do want to get in the habit of just doing it for both solution or both equations just to show your work. So I'm going to still plug in everything over here. Okay, now I'm going to clean it up. 2 times 2 is 4. 4 minus 3 is 1. 1 equals 1. Okay, so that is true. However, in order for this ordered pair to be a solution to this whole system, then it would have to work for both equations. Okay, and if you notice, it did not work with the first one. Okay, therefore, this would not be a solution. So I could just write no, not a solution. Okay. Now, these two lines, they will intersect, okay, because they have different slopes and different y-intercepts. So they will intersect at a point. It's just not 2, 1 that they will intersect at. It'll be another point. And finally, our last example of the day is we are going to test out 1, -4 into the following equations. Now, sometimes they're not going to be in slope-intercept form. Sometimes you'll see them in standard form. And that's okay. Just plug it in and figure it out. So I'm going to set up my 2 equations. Okay, I'm going to do 2x plus y equals -2 over here. And then I'm going to do -3x plus 2y equals -11 over here. This doesn't look like an equal sign. Okay, remember the x and then the y. So I'm going to substitute in everything. I'm going to do 2 times 1 plus -4. I'm going to put that in parentheses just so I don't get confused. Let's clean everything up. 2 times 1 is 2 plus -4 equals -2. 2 plus -4, different sign, subtract. So 4 plus 2, or 4 minus 2, I'm sorry, is 2. Keep the sign of the higher number, which is the 4. So that's going to be -2 equals -2. Ding, ding, ding. Okay, it works for that one. However, I can't just say, yes, it is a solution, because in order for it to be a solution, it needs to be a true statement for both example or both equations. So let's go over to the second one, and I'm going to do -3 times 1 plus 2 times -4 equals -11. -3 times 1 is -3 plus 2 times -4 is -8 equals -11. Now, -3 plus -8, so same signs, add and keep. So I'm going to add these two, and I'm going to get -11 equals -11. Ding, ding, ding. True statement. It works. So since it worked out for true statements, we had -2 equals -2, which is true, and we have -11 equals -11. That's another true statement. Then 1 -4 is a solution. So yes, it is a solution. Okay. Good. Okay, so that concludes my video for today. Okay, please carry on and continue the next assignment, which you're going to just do a couple practice problems on Google Slides. Please feel free to reach out to me at all during the day to, ask me any questions. I can jump onto your slide and help you out if you need to. But please, please, please do your best work and reach out to me. Also, just make sure you do your daily check-in as well. Okay, just so that I can mark you here for today. Okay, so good luck, guys. Have fun with today's lesson. It's great to be back working with you guys. And again, reach out to me at any time. Okay, bye, guys.